Oh, hello. Look at this little puzzle.
16p plus 1 equals k cubed.
It looks so polite, doesn't it?
Look, it's even wearing a tiny bow tie for us. But don't let the symmetry fool you.
It's hiding a dark secret behind that equal sign. It's like a math kitten, adorable, purring. Pshh.
Just waiting for us to make a wrong move.
Our mission? We're hunting down a specific prime number, p.
Primes, those antisocial numbers that don't like to share.
2, 3, 5. They only divide by themselves and 1.
We need this whole engine to snap into a perfect cube. I love poking a new problem with a stick to see if it bites. Let's try p equals 2, just to be friendly.
16 times 2 plus 1 is 33.
33? Boring. Definitely not a cube.
Wait, what about 3? 16 times 3 plus 1 is 49.
Wait, that is 7 squared. A gorgeous, perfect square.
I have a weakness for squares. I really do. But we're hunting for a cube today. Heartbreaking, really. If we keep guessing like this, I'll be 80 and retired.
I actually tried brute forcing this on my laptop. It's just numerical noise, a total dead end.
The fan started sounding like a jet engine.
The solution is hiding way further down the number line.
Deep in the numerical suburbs.
Let's look at the bones of this thing. It's algebraic DNA. The 16p plus 1 machinery is grinding away here. And our target, a perfect, shiny, beautiful cube.
Time to find the hidden rhythm, the pattern behind the curtain.
I can feel the gears shifting. Let's see where they lock.
See this plus 1? It is just loitering there.
It is totally killing the symmetry. Total vibe killer.
It is like that one puzzle piece from a different box that ends up in the wrong set. It just does not belong.
So let's kick it over to the right side
And see what kind of secret structure is hiding underneath. A quick subtraction and boom! Total geometric harmony.
Wait, stop. My math senses are tingling. Look at that right side. Is it just me, or does that look familiar? Difference of cubes, the skeleton key for unlocking beautiful patterns.
It just unravels so neatly into k minus words.
And this gloriously messy k squared plus k plus 1.
Oh, so much better. My brain is finally at peace.
Now look closely at 16. This is my favorite part.
It is just 4 little 2s in a trench coat.
Pretending to be one big number. This is a total heist.
And our mystery guest, Prime P. Look at it sparkle.
Now, over on the right side, we have 2 hungry buckets waiting for their share of the loot.
So, here is the billion-dollar question. We have got a pile of 2s and 2 very different buckets.
Which bucket gets the prime? And how do we split up the 2s?
It looks like a total mystery for now.
Get your detective hats on. It is time to crack this case.
Whoa, 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 red flag, pause right there.
We need to zoom in to the DNA of this specific term. K squared plus k plus 1. Looking all innocent. But see these first 2 terms? My eyes are absolutely glued to them.
Let's just peel back a layer.
Factor out a k.
K and K plus 1. They're next-door neighbors on the number line.
Think about it. In any pair of neighbors, one of them has to be even. So their product is definitely even, no matter what k is. Now, take that nice, reliable even number and add 1. Boom! It is strictly, undeniably odd. Let's stick a pin in that. Our parity lemma is going right into the toolbox. See this odd factor? It refuses to touch the 2's lurking inside that 16. Those 2's are getting bounced from the club. Access denied. The 16 has nowhere else to go. It has to dump all its weight into k minus 1. Which means 16 must divide k minus 1 perfectly. Clean, elegant, everything fits perfectly. I love it. Okay, look at this. 16 just decided it wants nothing
To do with this chunky factor, it's dumping all its baggage.
Onto the K minus 1 term?
Brutal, right?
And our chunky factor? It's definitely odd. Check the pattern.
K squared plus k is always even, so adding 1 makes it allergic to 2's.
This factor is having a bit of an identity crisis.
Since it has to divide 16 times p, but hates 2's, it only has 2 paths. Case 1 is a total buzzkill, like opening a treasure chest, only to find it is just full of lint. A total dead end. 0? -1? No thanks, not today. We need k to be positive for our cube to actually exist in the real world. But case 2, this is where the puzzle pieces finally click. Our chunky friend has to be p. There is literally no other way around it. Let's plug that back into the original mess and see what survives the explosion. Now we divide both sides by p. Since p is prime, it can't be 0, so this is totally legal. Look at that! The p terms just poof, evaporated into thin air. I honestly love seeing messy variables just dissolve. It is so satisfying. And just like that, k equals 17. Now we are really cooking. Moment of truth! Let's feed 17 into our p machine and see what kind of prime number pops out the other side. 307. It is big, it is weird, but is it actually prime? Wait, stop. Don't you dare start celebrating yet. If 307 isn't prime, our beautiful house of cards falls apart. Let's check. Primality test speedrun. Time to interrogate the suspects. Ready? Go. 2? No way. 307 is odd. It's not even trying to be divisible. 3? Digits sum to 10? Not in this house. 5? Doesn't end in 0 or 5. Hard pass. Next. 7, 11, 13? I checked them all. None of them fit. 17? 307 is 17 times 18 plus 1. It is clean. It is clear. It survived the test. 307 is prime. We actually found it. The math gods are smiling. Patterns are just gorgeous when they finally click, aren't they?